Okay, welcome Math 3 to inscribed angles. We ran through this on Friday and reviewed it again today. Looks like this. An inscribed angle is one whose vertex is on the circle. We can point that out right here. B is the vertex of the angle and it is on the circle. Down here, X is the vertex of the angle and it is on the circle. An inscribed angle we found out is half of the intercepted arc. Half of the intercepted arc. We did that in class the other day with the rubber band, if you remember. Therefore, just by using that fact, we now know that since arc MAC is 100 right here, arc MAC is 100, and since CAB is the inscribed angle, then it has to be half of that, which of course is 50. You can do the same thing if you know the angle and you don't know the arc. Keep the same thing in mind. Since we now know, or since we know that AXB is an inscribed angle, we know that that is exactly half of the arc. Okay, but in other words, instead of saying that the angle is half the arc, we could also say that the arc is twice the angle. So if I know the angle is 34, the arc that makes it, or that it makes, will be twice that, and that's where you can see the 68 came from. All right, looking at this second example here, we're trying to find the measure of angle ADC. I highlighted ADC, and I can see that ADC is an inscribed angle that has the arc AC. Well, since arc AC is 54, I know that ADC has to be half of that 54. I just wrote this algebraically instead. So it's very easy to see that the arc has to be 27. Now an interesting thing happens on this picture, and I wanted to point that out. Look at our angle ABC in blue. Notice that ABC is the same, even though the angle looks completely different and it's in a different location, notice it actually creates the same arc. So if the arcs are the same, then the angles must be the same, and that's what this tells us right here. We use that fact over on this other problem to help solve a problem for us. So we're looking, first thing I notice, of course, is that the 3x plus 7 angle, the purple angle, and the blue angle actually intercept the same exact arc, don't they? So because they're the same arc, we know that the angles have to be the same, and I can just use my algebra skills to find out what x is. Once you know x, you can always plug back in to find the missing angle. The fifth example we have here is I'm looking over here. I want you to recognize that I've got another inscribed angle, which is 50, and since we've already practiced this, we now know that the arc that it makes is 100, and that's pretty straightforward. Now, in blue right here, I've created what we call a central angle. Now, central angles are equal to the arc. So, since my central angle is equal to the arc, and this arc we just figured out is 100, I know the central angle is 100 as well. On this side, I've asked you to look at all sorts of things. I want you to name everything you could possibly name in this one. Now, generally, a problem's going to ask you for something very specific, but on this one, I'm just going to be generic, and we're going to figure out everything we can. First thing I notice is angle LNP. LNP creates arc LP, which is 92 degrees. So if LP is 92 degrees, that makes that little angle on the inside 46, because that's half of it. Okay, that's one thing I looked at. Go find something else. Okay, this time I'm going to focus on this triangle. Well, I really kind of wish I hadn't, but that's all right. We're going to look at this triangle. We know our triangle angle sum rule. I know 2 out of my 3 angles in a triangle, so that means if I add up 68 and 46 together, and then subtract that from 180, I'll get this third angle down here, which in this case is 66. Now notice where 66 is though. It's the whole angle. It's not those two little pieces. It's the whole angle there. Highlight something different. Let's go back to arcs and angles. Let's look at arc MLP. Arc MLP, if you'll notice, is created from a diameter, and we know that's called a semicircle. So together, arc PL and arc ML together make a semicircle. So I can take 180 minus the 92. That'll give me this little orange part up here, arc LM. I know the arc LM is now 88 degrees. In purple, I can see angle NLP is 68 degrees, and it creates arc PN. Well, NLP is an inscribed angle, so if I do twice that, I can get the angle as the arc is 136. Again, I'm trying to figure out all the little pieces. I have one little piece of an arc left of the circle. Now that little piece, there's a couple ways to look at it. I chose in class to recognize that I had a diameter, so that made a semicircle. So the purple arc PN, I subtract that away from 180 to get 44. Of course, some people recognize I could have done the entire circle at that point and just added 88, 92, and 136 together and subtracted that from 360. What else do I have left in here? Let's check out angle LPM. Notice that was part of that 66 earlier, but it creates this orange arc, which we already know is 88. So half of 88 is 44, and I write that down here. And now there's a couple ways I can figure out this other little piece. I can either take the 66 and minus the 44, or I can look at this arc here. So I'm going to look at the arc MPN. Since we found out that arc was 44, this inscribed angle is half of that, which is 22, which is the same thing as what we said earlier. So I've gone through all of them and figured it out. Again, most of the time you're only going to have to be asked one thing, but you might have to find a missing piece in order to find another piece somewhere else.